Welcome back to my channel, Math and Language, and we're going to discuss how to find any limit. So let's start with the techniques on how to find the limit. So the first one, we can do substitution or direct substitution. The second method or technique is factoring. Third one is common denominator. Fourth one is you can expand it. The fifth one is conjugate. And the last one will be trigonometry. So let's have the first method. First example also. What if we have like this? The limit of the function x plus 2 as x approaches 3. We can just directly substitute 3 to x. So that will be 3 plus 2. And 3 plus 2, that will be 5. So easy, right? Next one, example number 2. What if we have a polynomial or trinomial to be specific? The limit of the function x squared plus 2x plus 5 as x approaches 2. So what you can do is just directly substitute 2 to x. Just replace it. So we have 2 square here, 2 square plus 2 times 2 plus 5. 2 square, that will be 4, and 2 times 2 is 4 also, plus 5. 4 plus 4 is 8, plus 5, that will be 13. So the final answer to this question is 13. Let's move on to example number 3. Okay, we have a complicated problem. So in the numerator part, we have x squared minus 6x plus 9 over x squared plus 4x plus 4. We can do direct substitution. So just replace x with 1. So you have 1 squared minus 6 times 1 plus 9. And for the denominator, that will be 1 squared plus 4 times 1 plus 4. So 1 squared is 1, minus 6 times 1, that's 6, plus 9. 1 squared plus 4 plus 4. So let's simplify it. 1 minus 6, that will be negative 5, plus 9, that will be 4. And 1 plus 4 plus 4, just as is. 1 plus 4, that will be 5, plus 4, that will be 9. So the final answer will be 4 over 9. So in this question, the answer is 4 over 9. Let's move on. Example number 4. What if we have like this? The limit of the function 2 as x approaches negative 7. There's no variable. You only have a constant, like this one, 2. But it states here that x approaches negative 7. We don't have a variable, just copy. The answer will be as is, 2. Another one, if we have like this one, x approaches, for example, 0, and we have 3 here. So the answer will be still 3, as is. Now, example number 5. Okay, we have a radical sign. The, the limit of the function, the square root of the quantity negative x plus 9, as x approaches 3. Just directly substitute it. So that will be the square root of negative 3 plus 9. And the final answer will be square root of 6. Next example, number 6. What if we have like this? So we have x squared minus 4x plus 3 over x minus 1. Let's try direct substitution. So we have 1 squared minus 4 times 1 plus 3 over 1 minus 1. So in the numerator part, we have 1 minus 4 plus 3 over 0. And 1 minus 4 is negative 3 plus 3 is equal to 0 over 0. We cannot just do substitution. We cannot have 0 over 0 as our final answer. We have to do something else. So I will introduce you the second method. That will be factoring. So let's get back to the problem. We need to factor this one out. As much as possible, we cannot do direct substitution because 1 minus 1 is equal to 0. We cannot have a 0 in the denominator. So if we factor x squared minus 4x plus 3, that will be the quantity x minus 1 multiply to the quantity x minus 3. As you can see, we could cancel something like this one, x minus 1. Oh, like that. So the remaining part will be x minus 3. We can now do direct substitution. So replace x with 1. So 1 minus 3, that will be negative 2. So that is already the final answer to this question. Next one. What if we have example number 2? Okay, in the numerator part, we have 2x squared minus 12x plus 16 over x squared minus x minus 12. We can try direct substitution. Okay, just replace x with 4 and simplify further. Let's simplify the denominator first. We can see 4 squared, that will be 16, minus 4, that will be 12, minus 12, that will be 0. Again, we cannot have a 0 alone in the denominator. Yes, it's a big no. Thank you. So we have to try another method. So we have to do factoring since we have a trinomial here. So factor that one. So I'll just reduce this one to 2. So 2 times the quantity x squared minus 6x divided by 2 divided by 2. Okay, next up, we can factor this one, x squared minus 6x plus 8, as well as the denominator. So for x squared minus 6x plus 8, that will be x minus 4 and x minus 2. For x squared minus x minus 12, that will be x minus 4 and x plus 3. And as you can see, we could cancel these two. So that will be 2 times x minus 2 over x plus 3. Let's substitute the values. So let's replace x with 4. So that will be 2 times 4 minus 2. That will be 2 times 2 over 7. So 2 times 2, that will be 4 over 7. So we have a finite number, and that means that's cool. We got a good answer. I mean, the correct answer, I mean. So in this question, the answer is 4 over 7. Let's have the third example. What if we have this one? The limit of the function x squared plus 2x minus 8 over x squared plus 5x plus 4 as x approaches negative 1. Okay, we can do direct substitution again, but let's check the denominator. And negative 1, if you square it, that will be 1 minus 5 plus 4. So 1 minus 5 is negative 4 plus 4, that will be 0. So again, it's a big no. We cannot have this as our final answer. We have to do factoring. So let's try factoring. Okay, so the factor of x squared plus 2x minus 8 is the quantity x plus 4 multiplied to the quantity x minus 2. For the denominator part, x squared plus 5x plus 4, we have x plus 4 and x plus 1. And we have similar terms in the numerator and denominator. We could cancel them out. So the remaining part is x minus 2 over x plus 1. So let's try to substitute it. So negative 1 here. Negative 1 minus 2 is negative 3. And negative 1 plus 1 is 0. And again, we cannot have this kind of answer. So we already do direct substitution and factoring, but it doesn't give us a finite number. So the answer will be B and E, or does not exist. Moving on, let's go to common denominator. Let's have the first example. What if we have this kind of complex fraction? In the numerator part, we have 1/4 minus 1 over x, and in the denominator, we have 4 minus x. We can try direct substitution. Okay, so 4, so let me get my pointer back. 4 minus 4. So that will be 0. Okay. Again, we cannot have direct substitution because we cannot have a denominator. We cannot have 0 in our denominator alone. We can do factoring? No. we can't factor anything here. So we can try common denominator. So let's answer this one. So 1/4 minus 1x. So 1 times x, that will be x. And minus 1 minus 4 times 1, that will be 4. Over 4 times x, that will be 4x. And for the denominator, we have 4 minus x. So we can get the reciprocal of this one. Remember, a over b over c is equal to a over b times 1 over c. So this one will be like this, and c will be 1 over c, multiplication part. As you may have noticed, we have 4 minus x here and x minus 4. As much as possible, we need to reduce the, the function. Okay, so x minus 4 could be like this one. Negative quantity 4 minus x. How did it happen? Well, let's write having like this one. 5 minus 3 is equal to 2, right? We can change it to negative 3 minus 5, and we can still have the same answer. So negative quantity 3 minus 5, that will be negative 2. So negative and another negative, that will be positive. So I just transform this one, x minus 4, to negative quantity 4 minus x. So I need it so we can cancel these terms. So let's see. So we have like this. So cancel the 4 minus x, and we have negative 1. Of course, there should be a 1 there, even if there's no more number, over 4x. So that will be negative over 4 times 4. You substitute 4 to x. So that will be negative 1 over 16. And that's the final answer. For this kind of question, the answer is negative 1 over 16. Let's have another example. Okay, a more complicated one. In the numerator part, we have 1 over x plus 2. And you will subtract 1 half, minus 1 half. And the denominator will be x. Again, we cannot have direct substitution, because if you substitute it directly, we will have a 0 alone in the denominator. And we don't want to have that kind of answer. So we must do common denominator. What you just do, cross multiply 1 times 2 minus x minus 2. Okay, where did it came from? I'll just multiply 1 times x plus 2. 1 times x plus 2. But remember, there's a negative sign. So I have to distribute it. So that will be negative x minus 2. This one is this one. Okay, so denominator part, the middle part is, you just multiply this one. 2 times x plus 2. And of course, the bottom part, that will be the denominator. Moving on, you may have noticed that the 2 are gone, because 2 minus x minus 2, or 2 minus 2 is 0. So we are left with negative x over 2 times x plus 2 over x. Remember again the a over c, the reciprocal. So this one will be like this. Okay, I'll enclose it. And over x, that will be, you have to get the reciprocal, so you have to multiply it by 1 over x. And as you can see, we could cancel something like this one. Oh yes, thank you PowerPoint. Now we have negative times 1, negative 1 over the denominator 2 times the quantity x plus 2. We could now substitute 0 to the function. So we have negative 1 over 2 times 0 plus 2. And the final answer will be negative 1 over 4, or negative 1/4. Okay, next method, we have expand. Let's have the example. What if we have the limit of the function, the square of the quantity x plus 1, and you will minus 1 over x, like this one. Can we do direct substitution? Obviously no. If you put a 0 here, cannot be. So we could try factoring. We cannot do factoring in this kind of question because it's already factored. You can try to have common denominator. No, it's not a complex fraction. And what are you going to do with the common denominator? So we could try to expand it. So we have a square here, right? We could do FOIL method for this one. So the quantity x plus 1, if you square it, this will be the answer. Now, we could simplify this one. 1 minus 1 will be 0, so that will be erased or cancelled. So we are left between x squared plus 2x over x. Now, I just factor this one. X squared plus 2x is x times x plus 2. As you can see, we could cancel the x here. So we are left with x plus 2. Now, as x approaches 0, as stated in the problem, just substitute it. So 0 plus 2, that will be 2. And you already have the final answer. Let's have the next method. Conjugate. Example number 1. What if we have a square root like this one? And the problem, the limit of the function x minus 4 over the square root of x minus 2. 2 is not included in the radical sign. Now to get the conjugate, we just multiply it to the opposite sign. So remember, our basis of conjugation is where the square root is. So if it's square root of x minus 2, we just change the sign, that will be plus 2. Plus. But if it's, for example, if it's square root of x plus 2, then the conjugate will be the square root of x minus 2. The reason behind this is we have to get the difference of two squares. Remember this one? A minus b times a plus b will be a squared minus b squared. I'll explain later. So we have this one, and let's simplify it. So I don't want to make it messy, so I'll just put it as is, just putting some parentheses so it will not be confusing. Now, since this will be a difference of two squares, we have a minus here and a plus here. Square root of x, we just multiply a and b. Square root of x times square root of x, that will be x. And 2 minus 2 multiply to plus 2 or positive 2, that will be minus 4 or negative 4. Now, we could cancel the x minus 4 here. And we have left with just the quantity square root of x plus 2. Substitute the 4. So we have the square root of 4 plus 2. Square root of 4, that will be 2. 2 plus 2 is 4. So the answer to this question is 4. Let's go to conjugate example number 2. What if we have this kind of question? Okay, so the radical sign is now at the numerator part. So we have the function, the limit of the function, the square root of x plus 1 and minus 3 over x minus 8 as x approaches 8. We can do direct substitution. However, you can see there, if I put 8 here, 8 minus 8, that will become 0. So it's not acceptable. We can do factoring. We cannot factor anything. Common denominator? No. Can we expand something? No. So we can just do the conjugate part. So remember, our basis of conjugation is in the numerator part because that's where the square root is. So you multiply it by the square root of x plus 1 plus, because this is minus, we could plus this one. So you're just copy paste this one, copy paste it, and just change the sign. Now, remember difference of two squares. You're just going to multiply this one. But just to show you, because this will be cancelled out anyways. So the square root of x plus 1 multiplied to the square root of x plus 1 will be x plus 1. You're just removing the sign. It's just like this one. X plus 1 squared. So cancel the radical sign and the square or the exponent. So we have x plus 1 here. And negative 3 multiplied to positive 3, that will be negative 9. And for the denominator part, I just put some parentheses so that it will not be messy. Okay, you may have noticed that I just canceled this one. I just next is x plus 1 minus 9, so that will be x minus 8. Oh, look here, we could cancel something. So x minus 8 in the numerator part and x minus 8 in the denominator part. So the remaining will be, of course, there will be a 1 here. 1 over the quantity the square root of x plus 1 and plus 3. We can now substitute it directly. And for the denominator part, the square root of 8 plus 1, that will be the square root of 9. Square root of 9 plus 3. The square root of 9 plus square root of 9 is 3 plus 3, that will be 6. And of course the 1 here. So the final answer is 1 over 6. Let's move on to trigonometry. Now before I give some example, I just want to show you something. So if we have the limit of the function sine x over x and x approaches 0, the answer will be 1. Remember that one. And also, if you just flip it, the answer will still be the same. It will be 1. We have the limit of the function x over sine x as x approaches 0. Remember, it should approach 0. Okay, approach 0. Because if you put different number there, it will have a different answer. So let's have the first example. What if we have like this? So the limit of the function sine 5x over x. So we have a number here between sine and x. Remember, sine x over x is 1. So the remaining part, just multiply it to 5. And the answer will be 5. Easy, right? The next one. What if we have this one? Sine the limit of the function sine x over 5x as x approaches 0. Always remember as x approaches 0, okay? Remember, sine x over x is equal to 1. And we have 5 in the denominator, or you can say 1/5. So the final answer will be 1/5. Easy. Next one. Example number 3. What if we have, okay, there's a number in the numerator part between sine and x, and a number beside x. Again, remember sine x over x is equal to 1 as long as x approaches 0. So 10 over 5, that will be 2. We just simplify the fraction. Example number 4. What if we have, okay, a number beside the left side of sine, and a number between sine and x, and a number beside at the denominator beside x. Again, remember, as long as sine x is there and x approaches 0, that will be 1. We just simplify this one. 3 times 10, that will be 30. 3 times 10 is 30 over 5. So that will be 6. Example number 5. What if we have, okay, I just flip it. X over sine 2x. Again, x approaches 0. Remember, x over sine x is equal to 1. But this one, the 2 is in the denominator, so that will be considered as 1/2. So 1/2 times 1, that will be 1/2. Moving on. What if we have this one? So again, I just flip the x and sine x, but 7 over 2. Again, x over sine x, that will be 1 as x approaches 0. And we have 7 over 2 here. So the final answer will be 7 over 2. The last example, Alright, I think this is not the last example. What if we have x plus sine x over x as x approaches 0? Okay, so how can you do this? We must do some algebra. We need to distribute the denominator. So that will be like this one. X over x plus sine x over x. So x over x is equal to 1. And sine x over x is like this one. We know that sine x over x, that will be 1. And of course, 1 is as is. 1 plus 1 is 2. If you encounter like this one, you can just try to distribute the denominator. Okay, so let's have the last example. What if we have like this? The limit of the function tan x over x as x approaches 0. Remember your trig identities. So tangent is sine over cosine. So I'll put it like this one. Sine x over cosine x. Now we have a denominator of x, so I'll multiply 1 over x here. Remember, sine x over x is 1. So I'll just switch it. There will not be a problem because it's a multiplication. It's multiplication. So let's do it part by part. The limit of the function sine x over x as x approaches 0, that will be 1. And the limit of the function 1 over cosine x as x approaches 0 is also 1. Remember this one. This is also 1. So we have here 1 times 1 is equal to 1. And that's already the final answer. So if we have the question like the limit of tan x over x as x approaches 0, the answer will be 1. And that's the end of the lesson on how to find any limit. If you would like to comment or suggest another math and language video, please comment down below. And also, if you need help with your assignment or module, I'll do my best to answer it. And also, comment down it below. Again, this is James, your math and language instructor. Please like and subscribe, and also click the bell notification so you will be updated on my future videos about math and language. Thank you and goodbye.